Hello, everyone, and welcome to the next episode of the Belinda Carr Show. Today, we're going to be talking about space architecture.
So you haven't made a previous video on space architecture?
No, I didn't even really know there was a field that existed. I always thought it was something fantastical, something that architecture students might do in school, but not something that occurs in real life.
I do recall seeing a few projects from people wanting to do like space design, but the professors always
Shot it down?
They always turned it down because there's too many unknowns, too many obstacles, too many hurdles for them to properly critique it.
Do you think that wouldn't really stop architecture professors because they don't really critique other projects very realistically? But I get what you mean. Yeah, there was this one guy at our architecture school who'd always think outside the box. And his eventual design was like pyramids sticking out of the ground. And I don't know if he had some sort of underground structure and these were light wells, but that's all his model was, just glass pyramids on the ground.
So you can't talk about space architecture without bringing up a TV series that we just finished called The Expanse.
Awesome TV show. Well, the first 2.5 seasons are awesome. Just stop watching after that.
But it's really cool to see how realistic they are with like the propulsion systems and gravity and adapting to those different climates. Architects or designers could take a note from that show and how you need to approach designing in space, like from a more realistic standpoint.
Absolutely. That's a very good point because none of the orbiting stations or even the structures on planets like on Ganymede, they weren't out of this world, unrealistic buildings. They didn't have angles and curves for the sake of having it. It's not just that because we're in outer space, we can do what we want. No, we're still limited by materials and cost, money, and the environment over there. There are a lot of variables we need to consider. So all the structures are still very realistic and very similar to something that you could find on Earth.
It's a good point you bring up, but if you look at the International Space Station and from an architecture standpoint, it's like, what is this? It's just all these parts and pieces stuck on there and it's just ever expanding, but they don't have the same constraints that you have on Earth. And so whenever you see these designs for these space structures, these structures on Mars or on the moon or something, and there are these sexy facades and things like that, it's like, that's not realistic.
But I guess there's a difference over there because in the space station, humans are there for a couple of months or maybe a year or so. But when you think about Mars, we're thinking about long-term living. And that's when architecture design would have to come into play because it really affects your psychology. If you're in a space like if you're in an environment like the space station that's been designed purely for practicality, purely by engineers.
Was it designed by Le Corbusier? Because function over form?
The opposite, yeah. So I think having all those buttons and angular angular hallways and all that stuff, it's very, again, very practical. So I think in the long term that could affect your mental health.
Yeah, I think at the beginning, whenever we start to deploy these structures to the moon and to Mars, it's going to be these very practical, the cheapest possible way we can build. But over time, hundreds of years, once we get settled onto these new planets, and we'll start to look into architecture more.
It's not a necessity in the beginning. There are far more important things to consider, like materials that you're going to use and how you're going to survive in that environment. You have to be overcautious, and then we can start playing around with designs or thickness of walls. And once we understand the radiation levels on Mars and the water supply on the planet and all that stuff, that's when we can start playing around with architecture.
Yeah, and we make, or at least I make architecture sound like it's just making pretty shapes and funky forms and stuff like that, but it's really not. And there are a lot of architects out there that are exploring this idea of space architecture and what it would be like to be on these other planets, and they're looking at it from a very critical perspective while also adding in that aesthetic.
And I spoke to one of them recently, a really passionate creative architect who's trying to simulate the environment on the moon here on Earth. So today we have Sebastian Aristotelis of SAGA Space Architects, all the way from Denmark. Thanks for joining us, Sebastian.
Thank you for having me.
So tell me a little bit about how you got into space architecture.
It's not like I woke up one morning and I was like, okay, space architecture, I want to design and build houses for the moon. But it was a gradual kind of change, right? So I think it started out when I was very, very young, just being fascinated by exploration and the unknown, right? There's this deep fascination, and of course, when you're a kid, it's also like a fascination of fairy tales and Pokemon and all of these like things that kids love, right? But I had this intense hunger for just exploration, and it just so happens that we live in a time where most of the world is already explored. Like most of planet Earth is already pretty well explored. The jungles, the deserts, the deep oceans. Of course, still a lot to see in the deep oceans, but it's not as like people have been to the Mariana Trench several times, right? It's not unexplored territory. So that made it quite natural for me
to look beyond the Earth.
Exactly, to look beyond, to look up, to look at the stars and imagine what is out there. And then, you know, growing up, I was always building things, drawing and building things, gadgets and technology and stuff like that, like building with my own hands, and was fascinated of creation. And then it just so happens that as I'm getting older, my skill sets and my interest is more and more in architecture. But I still love space. And then I knew I wanted to do, so if there was a chance that I could do something with space, that would just be amazing. So I said, okay, if I take what I believe is important and interesting, and if I look at what I'm good at, and then just put it together.
Were you encouraged to explore that in architecture school?
In the beginning, no.
No.
I mean, people thought it was funny and cute, right? It's like it's like, okay, this guy wants to do space architecture. But yeah, so I kept it to myself, actually as much as possible. Then luckily I met one student, and somehow the conversation landed on Mars, the red planet, and we talked about that, and he had read a lot of things about it, and I had read a lot of things about it. And for the first time, I met someone who I could ping pong with, you know, who somehow was like we both knew a lot about it. So, and that guy was Carl, and he ended up being my co-founder of SAGA Architects. And but we still kind of kept it to ourselves, because people kind of think you're a little bit crazy. But we would meet once a week and kind of discuss, how does someone get into space architecture? There's not really that many people you can ask, especially at that time. Now there's a couple more, and people ask me a lot, like, how do I get into it? And I'm telling them, there's no direct way. You got to pave your own road.
You all started this company almost straight out of architecture school, didn't you?
Yeah, we did. So we studied together. We decided, when there is a Mars architecture competition, another one. We had seen a couple of international architecture concept competitions, and we said, when there is another one about the moon or Mars or in orbit, we're going to participate. And we waited for a few months and nothing was coming up, and then all of a sudden there was one, and we said, okay, we're going to go all in on this. So it was a competition called Marstopia, made by 11 magazine. Unfortunately, the company doesn't exist anymore, but at the time it was the biggest Mars architecture concept competition in the world. And we participated in it. And at that time I was living in Australia, and Carl was living here in Denmark. We were both from Denmark. So I was working when he was sleeping, and the other way around. And we were sitting on our laptops and just making these competitions. And then we ended up winning. And that was like, I think that was incredibly important, because it gave us like some confidence, and we really needed that confidence. And then we used that competition winning to apply to the International Space University, which is like, I used to say it's like the Hogwarts of space. Like if you want to go somewhere and learn all about not magic but all about space, space law, space engineering, aerospace engineering, space architecture, all of these things related to space, then go to the International Space University. It's in Strasbourg, and every summer they have a very intense 9-week course where you sleep at the institute and you work together with 130 people from the industry. And we did that. And at that point, we didn't like, it was not the plan to directly start our own company, like SAGA Space Architects. That seemed like a big jump. But meeting these people from NASA and ESA, and they were constantly encouraging, like they said, like, you guys look at this thing different than we're used to seeing. And I think that encouragement kind of gave us another level of confidence. And then we were like, okay, let's just try it out. At that point, I was like 24 and Carl was like 22. Like we were also really like young, right? So I was like, we don't have kids, we have no obligations, we just finished school. Let's just do it. Like we don't need any, we don't like, we can survive for almost no money. And that's what happened. And then Carl moved into my apartment. He slept on my couch for 9 months, and we just lived worked out of my living room, like 7 days a week for 9 months, and earned like almost absolutely no money. And all the money we earned, we used to travel to places to design and build architecture. So we traveled to the desert to build DMAS, the laboratory, and yeah, it was a pretty wild time. And now, of course, it's 3.5 years later, and we are 11 people full time. So
yeah, it's quite a big team. It's a very impressive. Good for you.
I'm amazed by it myself. I'm like, fucking, like this is what I always dreamt about, having my own architecture firm and doing projects that we are passionate and proud of. And I think we're doing it.
I guess that's the big piece of advice to anyone coming out of architecture school. Don't wait. This, like you said, you're young, you're ambitious, you're really passionate about something. Go for it.
Yes,
it's not going to be easy, but
it is not going to be easy. But I would also add that it's also good with a little bit of experience. Like for some of the things we did, especially in the beginning, we made a lot of mistakes but I guess it's not a good or a bad thing, but we like having a couple of years in the industry, I think it can also be a good thing, because you just know the processes, you just know it a little bit. Now we know it, of course, but it was a struggle in the beginning, right?
Yeah, I think there's a phrase here in the States. They say drinking from the fire hose. Means like,
yes, exactly. Yes, yeah. I can completely see that in my head. You're just like, rah.
Yeah.
I completely see that. And but that's sometimes also the best way to learn. Just like jump into the waters, and then you'll learn to swim, right? It's like yeah. And the good thing about not having worked that much in the industry, of course, we worked when we were students. We worked for a couple of different architecture firms, but not having that much experience, it also frees you a little bit to create something that hasn't been seen before. Like you don't take solutions for granted. Like every time we were doing something, and it's almost still like that, we don't know all the standard solutions, so we make up our own solutions.
Especially when it comes to what y'all are doing with space design, where you can use completely different materials, things that are not used in regular buildings.
Yeah,
it's good to think out of the box in that way.
Yeah, 100%. And another weird thing is, like, most of the architecture that we have drawn, we have also ended up building ourselves. So, and that came from necessity. So me and Carl, I grew up in my granddad's workshop, and building stuff was like natural to me. And Carl grew up in his dad's workshop. So we've always been building stuff, and it's the same for the entire team. Like, it's all people who have, of course, a very good theoretical understanding, but our office is 20% office and 80% workshop. Like we have large CNC machines, and we have tools, all the hand tools you could dream of, and electrical workshop. So we have all the facilities. Of course, we didn't have that in the beginning. In the beginning, we were just like soldering wires together in my apartment, but now we have all the tools. but so we also built stuff ourselves, and and that's also a little bit weird, because when we did a project like Lunark, our simulated moon habitat that we tested in Greenland last year, there almost exists no drawings of it, because we were building it ourselves. Usually you have drawings because you send it out to someone, the contractor, to do it for you, but we were building everything ourselves. So we would just go in, print directly from the screen, and bring the laptop down to the workshop, or send the files directly to the CNC machine. So there almost exists no, like, most of the drawings of Lunark, like architectural drawings and detailed drawings, are made, like we made after the expedition ended, which just to communicate the project, which is really weird. Yeah.
Let's discuss that a little bit more, because that's fascinating. It's this compressed deployable structure that's based on like an origami design, right? And then you shipped it all the way to the North Pole, Greenland, and expanded it on site and lived in there for 60 days. Is that right?
Yes, that's completely correct. You know, and listening to you explain it, it also sounds like I can hear how it sounds. It sounds like a crazy project, and it was. But what we set out to do was to test. So there has been done simulation missions all around the world. In space language, you call it like analog missions, and it's basically where you put some people together in in an environment that is realistic to outer space, to the stressors that astronauts would experience in outer space. There's one on the top of a volcano, there's one in the desert. We also built something for an analog mission in the desert simulating Mars.
In Israel, right?
In Israel, exactly, yeah, in the Negev desert of Israel. But so there are these all around the world. The problem is, like, first of all, the architecture in many of these places are secondary. Like, it takes a lot of funding to do research like this, and so the architecture is not a priority. So it's secondary. So they often take like old silos, or like corn storage units, and retrofit it because then it has about the dimensions of a rocket, you know, stuff like that. And what we wanted to do was say, okay, what if architecture's first? Like our entire mission was to test architecture, because we believe that architecture, you can design it as a countermeasure for some of the stress that astronauts experience. But then to test the architecture, it was also important that we simulated a realistic environment. And in realistic, I mean like a real stressful environment, because we cannot test how the architecture works as countermeasure if it's not a stressful environment, right? Like
that's what's so great about your company. Like, going through architecture school, professors encourage us to come up with all these outrageous designs. It's just designed for the sake of design. But you all have gone a step further, and you all have designed intentionally. Like, every decision you make has an intention, and then you go another step and go and test it out in extreme conditions. I mean, we can't mimic the exact conditions on the moon and Mars, but you're coming as close to it as you can.
Yes, yeah, you're absolutely right. It's like we basically sat down and had a long talk about where on Earth is the most realistic place if you want to test something that's going to the moon. And basically you have the poles, you have the South Pole and the North Pole. Because we were in Denmark, because of logistics, getting to the North Pole is much easier than getting to the South Pole. There's also not that, you know, like, yeah, just like logistics in the South Pole is just effects are more difficult than the North Pole. But yeah, so the North Pole is great because it's isolated. You are completely far away from everything. If you fall and break your leg, you have to treat it yourself. Yeah, and that creates stress, because you're always, every time you pick up a power tool, like every time we had to fix something, you're very afraid of cutting yourself, because you know the road to the hospital is like 3 days. You know, like it's if the helicopter can even come and get you, right? So it's like, so it's isolated. Then the lighting conditions are similar to the moon. We had 30 days of sunlight in the beginning, where the sun didn't go below the horizon. The last 30 days of the expedition, the sun didn't rise above the horizon, right? So it was completely dark. And that also creates stress. That you have the cold, so it's extremely cold. So that also forces you to be inside the 4.5 square meter habitat all the time, basically, because being outside is minus 30 degrees Celsius, and the wind chill is like minus 41. And I know it's minus 41 because minus 41 is where Celsius and Fahrenheit kind of overlap. So so that's for the Americans out there, I guess. But yeah, so we chose that site very carefully. And then we spent 9 months developing the origami pattern that can fold. In the beginning of the project, we reached out to all the people in the world that we could find. Robert Lang from NASA, like a mathematician, an origami expert. And he said, guys, super interesting project. I thought about it before. It's not possible, but I'll work on it for $300 an hour or something like that. And we were like, at that point, it was just me and Carl sitting, you know, like together, and we were like, we almost couldn't afford food, right? Because everything, all the money we got, we would spend on like developing this thing. So we were like, okay, fuck it, we'll do it ourselves. And then we spent 9 months developing the origami until we finally had a geometry that would fold. And the funny thing is, he was right. Theoretically, it's not possible, but because he didn't take into account the, you know, the flexibility and the stretch that is in the materials in the real world, it was actually possible. So it was just about finding and
the right material to use.
Exactly, the right material to use and the right dimensioning of that material.
So what material did you use? Was it like an aluminum frame with the material stretched over it?
No, so yeah, so the entire structural part of the habitat is aluminum, and there's 2 practical reasons for that. First of all, 3 reasons. So first of all, it's lightweight. That's great. We were 2 people moving this, even though it was a lightweight habitat. It's still like a 800 kilo structure you need to move around. 2 people in the Arctic, it's still pretty heavy. But so it's lightweight. It performs great in the cold. You don't want to touch it because that'll give you frostbite real quick because it transfers like heat. It's very heat conductive. But and then the third reason, which I think is also one of the most important reasons, is we could machine it ourselves. Like aluminium is softer than steel. Of course, you need a little bit more thickness and stuff like that, but we can machine it ourselves. And since we were building everything ourselves, that was very important. So that's the structural part. Then the envelope, like the actual origami shell that folds, that keeps a pressure inside and keeps us safe and warm inside, that's made out of carbon fiber. So it's actually these sandwich panels, which is first like 0.5 millimeter of carbon fiber, then I believe it's 9 millimeters of like an insulation foam, a hard rigid armor cell insulation foam, and then another 0.5 millimeter of carbon fiber. So it's practically like these 9 millimeters sheets of sandwich panels that are super lightweight and super strong, like very stiff and very strong.
But really good insulators.
They are okay insulators. Like for its thickness, it's a good insulator. But we still had to add like another level of insulation on top of that on the inside. But
did you look into aerogel blankets?
We did. We looked a lot at aerogel, and you just go up in like. I mean, that would be nice. Like we would love to do that, but you just go up in price. Like carbon fiber already is it's so difficult. Exactly, and also getting that volume. I think we had 43 square meters of insulation in the habitat, if I remember correctly. Is that no? That can't be right. I don't know. It's such a long time.
Pretty expensive.
Yeah, but it would have been expensive, right?
Yeah.
But in the habitat, the flexible seam was a rubber with a nylon fiber in it, and that was like the key. That was like the golden key that made this whole thing work. So it took a long time to find a material that was flexible enough to fold and do the folding, but that could stretch enough to give us the tolerances for the entire structure, and that was strong enough that it could actually, because in Greenland you have some of the where we are from the ice caps, you have like these very strong winds, these fall winds that are some of the strongest winds ever recorded in human history.
So it can't be too rigid because it'll topple over. It needs some sort of movement. Is that it?
It needs a little bit of movement, but it also needs to be rigid enough that it doesn't just like, so it's not like a tent that's just like standing. And yeah, so it was all a balance, and like this combination of these two materials, like the carbon fiber and the rubber, was like it.
And you all went there in 2020, correct?
Yeah, so we went
So
there.
The rest of the world was isolating in their homes. You all isolated in Greenland.
Yeah, and the crazy thing was, yeah. So first of all, developing something like this and doing all the logistics while Corona is happening was the worst thing I've ever tried. Like, we were the only research expedition in Greenland in that entire season.
Oh my gosh.
All the research projects were just falling like flies. And we were like, but the only reason why I think we succeeded was because we were independent. All the other research projects, they were run
Funded
mainly, yeah, but by like universities and these large organizational structures that were hit very hard by COVID. But because we were independent, we could take higher risk. We were sending ourselves, like I can take personally as much risk as I want. So we were a bit more agile, and we could navigate the restrictions much easier. So yeah, so we made it work. But when we were there, we didn't have internet. So we actually thought that when we got back, that COVID would be like gone. So we were very surprised when we landed. Like after, our entire expedition was 3 months. We lived 2 months inside the habitat, but it took us 1 month to set the camp up and unfold everything. So we were gone for almost 100 days. And when we got back, we were very surprised that, we still had to wear like face masks and all of that.
Yeah, I was reading all them. You send daily messages back to your team in Denmark. I was going through some of them, and they're pretty hilarious.
I'm so happy you're reading it. I don't know how many people are actually reading it, but we were, yeah, every day we would send like one sentence back home over our satellite phone. So we didn't have internet, but we could set like using the Iridium network. It's this somewhat old constellation of satellites, and it worked pretty well. Yeah, so we could send like an update back, like yeah, and I should probably go back and read that. I think it'll be fun for me to read.
So did that project get a lot of attention, and a lot of companies approached you because of what you did?
Yeah, so yeah, 100%. So that was a very important thing for us to do. First of all, we were the developer ourselves. We were the designers. We also did all the manufacturing, all the logistics and planning, all the fundraising. We were even the crew ourselves. Like, we did everything ourselves. And I don't know if I'm not going to recommend that to other people. I think it's like too much to do. And now we are focusing more on some of the phases. Like, you cannot realistically be the best at all of it. But we did. We had to do all the fundraising ourselves. That also meant that we early on knew that we needed to do a lot of corporate partnerships. So, for example, all the carbon fiber was sponsored by Armacell and one of their subcontractors, and all the aluminum came from another partner, and the shipping, the actual habitat, came from a third partner. So in total we had 50 different partners that kind of came together and made this happen. Yeah. It was crazy. That's something people don't even think about when you make a project like this. That just like the organization of all of these stakeholders is about.
So how do you go from space architecture to 3D printing on Earth?
Yeah, so
because you have built a home in Denmark, is that right?
Yes, exactly. So together with the 3DCP group, it's kind of a consortium that we are part of, where we are doing the architecture. We are making the print files as well. Then we have the engineers who are doing all the static FEM simulations, all the building details, all the permitting, all of that, all the analysis. And then we have the developer. So it's like a consortium where it's like I don't know what you call it in English, like a full stop shop. Is that what you say? Like a full stop shop?
They call it, like, I think turnkey.
Yeah. Okay. Turnkey.
Exactly. Same thing. Yeah.
Yeah. So like, do you want a house? Okay, we will design it for you, print it for you, and also be the general contractor for it for you. Yeah, so that's called 3DCP Group, and we do the architecture. But we just printed the largest concrete house in Scandinavia this summer. We are working very hard to print the next couple of houses now. But we have always been interested in first technology.
Yeah.
I mean, we've always been fascinated by technology in different fields. But we've always been fascinated by 3D printing. Like me and Carl, we were the first people at the architecture school in Copenhagen to 3D print. Like Carl started the 3D printing lab with small FDM printers. And I was the first customer there, you know, like I was like, show me, like what is this machine and how can we use it? And we knew from that point on, like it was just a time, like it was just a matter of time when it would be available in a larger size, and we just followed the development. And at one point when we started the SAGA, we sat down for a weekend and we said, okay, let's do some research. What is the state of the art of large scale 3D printing? And we made a document of companies all around the world. And I believe at that point we found like 16 companies, and there was like Shanghai and Russia and the Netherlands and America, of course, like United States. And then it said like Denmark, and then it said a street name that I knew, like it was like 2 kilometers away, you know, and I'm like, wait, there's a company in Denmark that does 3D printing at this large scale. This is a few years ago now, and it's Cobot. And we just sent them an email and said, hey, we are doing this project in Vietnam. We want to 3D print it with your printer. Do you want to collaborate? Unfortunately, the project never happened, but then we got busy doing Lunak, the project in Greenland. But as soon as I got back last year from Greenland, the first thing I did was take contact with Coben and said, where's your printer now? How far has the technology come in the 2 years where my head has been in Lunak and where I've been like not paying attention to anything else? And then they said, this is how far it is. And then they introduced us to some guys, and then we started 3DCP Group with the other partners. Yeah.
That's fascinating. So it's crazy how far the technology has come in just 2 years. You talk about in 2020, it was this little Cobot was this little company in Denmark, and now it's one of the largest 3D printing manufacturers in the world.
Yeah, well, when we contacted, it's longer ago than 2 years, but and they were definitely not as big as they are now.
Yeah.
They were still like a pretty established company, but they are like, now they are, of course, like when you go to their facilities, it's quite impressive. But yeah, and that was also comforting because we knew like the technology also, it still needs to go, like, you know, the technology and the material and the material science, like they run in parallel, but they need to go quite a bit further before it'll be a mainstream thing, right? Yes. Like we are still I think everybody knows that it's there's still some time to go, but it's just very comforting to see at what speed it's happening.
Yes.
Like it's so fast now. It's very cool. Yeah.
So have you done a lot of research into geopolymers or other sort of polymers, like alternatives to concrete in 3D printing?
So I wouldn't say a lot of research, but we've definitely done research. I would say what we specialize in is more how do we use the technology to its full potential. So for example, like for 3D printing, what we are really working on is how can we make overhangs? Like how can we make architecture that follows the rules of overhangs as the technology allows it right now? Because I think it is inevitable if 3D printing technology needs to fulfill its true potential, we need overhangs, and we need to be able to print not horizontally but going horizontally as well. So we are working a lot on that and figuring out different, like we are very much on the geometry side, right? So what can we do with the geometry that allows for that? And then of course all of a sudden you realize that looking back at old architecture like masonry architecture and all these like Gothic architecture and ceilings of churches and all of these things, there's actually a lot of inspiration because it's a stacked geometry in a way, like it's all
That's
pentagon.
true. Yeah.
Yeah. So yeah, and that's also cool because that kind of brings back. So because when you look at something like that, I think the reason why a lot of it looks beautiful is because it follows rules in nature,
Mm-hmm.
right? It follows a parabolic curve, or it follows another curve that you
A
can just
golden
see the
ratio or something. There are
exactly.
things that you don't really know, but there's actual intention behind the design. Yeah.
Yes, and you can just almost, like, if it's done correctly, you can just read the physics of it, like, intuitively. So those are some of the things that we're looking at. And I wouldn't say that we are not material experts. We really try to just talk with the material experts of the world. But yeah, but we are looking a lot into to polymers right now, and the reason is we are doing our next habitat design. So Lunak, we finished it 1 year ago. There's an exhibition at the Danish Architecture Center in Denmark. It just opened 2 weeks ago, where we brought back the habitat from Greenland and put it inside an exhibition hall, so you can actually step inside the habitat and see what it's like to live on 4.5 square meters, and it
That's
still smell.
cool.
It's
When,
yeah, and it
how
yeah,
long is it going to be up?
for like 8 months or something,
That's awesome.
until October. I cannot
Okay.
calculate how many months it is, but I think it's like 8 months or something. October 2022. Yeah, and of course there's the entire, like, the habitat is the centerpiece, but there's entire explanation of our process. How did we go from idea to final habitat, and all the prototypes in between, and why does it look like it does, and all of this thing. But yeah, so that habitat was 1 year ago. Now we have for the last half year designed our next habitat. So we are taking all the things that we learned from Greenland, and then put it into our new design. And
And is that the Rosenberg?
that's the Rosenberg habitat. Yeah, exactly. So
Where'd
a
you
lot
come
of
up with that name?
that's yeah. So that's because the client is an old boarding school called the Institute of dem Rosenberg, and I'm sure I'm butchering the name. It's a client in Switzerland, and I'm sorry if they're listening right now. But so it's a habitat that it's another simulated habitat, but it's used for education and research. So it'll be simulation missions, but much shorter periods. So not 2 months like me and Carl did. Most people cannot fit that into their schedule of their life. So it'll be shorter trips of up to 1 week at a time. But yes, but that's it's a small footprint. It's about 6 square meters in footprint, but it's 6.5 meters tall, so it's almost standing like a tower. And we're going to 3D print the exterior shell out of thermoplastics, out of some kind of polymer. And right now we are in the process of defining that polymer and what kind of fibers we are putting in it to get the properties that we need. So I cannot go too much into detail of it, but it will be the tallest polymer structure that is 3D printed, as far as I can see. I've been looking all around the world and I cannot find anything that's taller. So I believe it is, but please correct me if I'm wrong. Then, like, send me an email and say that's not true, Sebastian.
So the structure itself has these like carvings on the outside that kind of look like
Yeah.
fingerprints that have gone into clay.
Yes.
So what's the reasoning behind that?
So it's okay. So first of all, it's important to explain that if you send anything into outer space, the structure will experience the vacuum of outer space, and that's fine if there's nothing living inside of it. But as long as there's anything living inside of it, you need to create artificially an atmospheric pressure, or close to one atmospheric pressure. So to withstand that pressure inside the volume, you need to have a shell that obviously is airtight. It's a pressure volume, but that also needs to be strong enough to keep one atmospheric pressure. So what we did with our structure was we used topology optimization. So the entire surface is optimized and only added reinforcement exactly where it's necessary to withstand that. But it's taking into consideration all the different, like we have openings for the airlock for humans to go in and out. We also have some windows, and all of that, of course, changes the forces on the structure. And the topology optimization scripts that we built for it takes all of that into account, and then it gives you like the optimal surface structure to do that. And what's interesting with 3D printing is that it would have been extremely difficult to machine, this structure with any other manufacturing method. I'm sure it's possible you could do like molding and casting of like glass fiber or carbon fiber shells, but that would be incredibly labor intensive, and some of the shapes that we have developed wouldn't be possible to get. So that's why we looked to 3D printing, and we basically just looked all around the world, and we found a company called Ingersoll, who was one of the only companies in the world that had a printer large enough to do a project like this. So they're collaborating with us with the printing facility in Milano, and they have all the technical know-how of printing a panel this size.
That's fascinating. And you said this is going to be installed in Switzerland?
Yes. So similar to none of our architecture. So our 3D printed concrete house, that's the only piece of architecture that's in Denmark. Everything else has been like in the desert and in the Arctic and like in Vietnam and now Switzerland. So we are getting pretty used to like figuring out how to ship these kind of things. So the habitat is made in 3 different sections, and then they can be taken apart. It's in pretty big sections, so you need some machines for this, but the habitat can be taken apart, and then it can be shipped on a large truck to Switzerland, and then we will assemble it on site. But only 3 parts. So it's not that much assembly. It's almost
like slots in place on site almost.
Exactly. Yeah, exactly.
Fascinating. What else do you have planned for the rest of this year?
So that's a good question. I mean, we just started manufacturing the habitat. So we are getting the first parts back from the machine shop, the first metal parts. So we will begin welding on Friday for the structural skillet of the structure. So for the next few months, I'm just heads deep in manufacturing. Like it'll be like the entire team will just get their hands dirty building this stuff. And like I think this is the phase where things really go wrong. It's also a very expensive phase, but it's also at the same time like the most rewarding phase, because like you've been working digitally for 6 months, and now finally like everything just
come together.
Yes, yeah. And not just seeing it come together, but also feeling it come together. Like you can walk inside of it and you can touch it and feel it.
It's when theory becomes practical. Like you can design on your computer all day long and just think it works, but when you actually go to the wood shop and start putting stuff together, you're like, no, that doesn't work. I need to rethink that.
Yes,
design.
Exactly. Yeah, and we're lucky that our office is literally like you can literally look through windows from our office into our workshop. So the iterative process is quite fast, and there's still some design decisions that we have left open, because we know as soon as we walk into it, we will get a better understanding of it. And then of course we are really working hard on 3D printing, designing buildings for 3D printing and concrete with 3DCP group. So that's one of our really big focuses. Is also building more for like general housing for people to live in here on Earth. And we're working on one pretty big 3D printing project, but I can't say too much about it. But I hope that we will do something public about it soon, because if everything comes together and this thing is going to be built, it'll be one of the coolest things that we've ever worked on, I think.
That's awesome. Okay, I'm gonna keep checking your website for that announcement.
Yes, but I mean, we the next few months it's going to be a lot of manufacturing, a lot of production. But it's so cool. I love it. I can't wait to put everything together.
It's beautiful to see how passionate you are about this. And thank you so much for sharing your journey and all these projects with us. Really appreciate it, Sebastian.
Of course, it was my pleasure. I just love talking about these things, and I have seen a lot of your videos already. So it's just funny to be in one of them myself.
I'm glad you joined us. Thanks.
So Sebastian seems like one of those really passionate architecture students who's carried that passion from school to the real world.
Yeah, he reminds me of what I was like in undergrad. Because by graduate school, we had all these co-ops and we had gotten onto the real world and we were jaded and cynical, but that pure, unadulterated passion that I had for architecture in undergrad, I can see a lot of that in him. And it's so great that he jumped into this in school. He didn't wait. And I know he was in the interview, he said that if he had waited, if he had worked at a typical architecture firm, there's certain things he could have learned. And when he was doing the space architecture, he could have used that knowledge and not made as many mistakes. But I think that going on in the real world would have curbed his creativity and impeded this whole lunar exploration in a way that wasn't impeded because he didn't have that experience.
I don't think it ever really works that way. You can't go into the real world and do the boring 8-to-5 job and then jump into the really creative thing. That's so much harder to do. He reminds me a lot of like Matty Mead from Himpotecture. He also started working on his desire, his dream in college. And so it seems to be a common thread with a lot of these entrepreneurs, let's say, that they have an idea in college and they're able to carry it through once they graduate.
I don't want to say capitalism is bad and capitalism corrupts you, but what you're saying is kind of implying that, like, when you get into the real world and you see what money can do, what the role of money in our work, you change your mindset.
You get complacent, and it's possible to jump back into it, but my advice would be, if you have that strong passion right out of school, like we both had, pursue it.
Because then you could do something absolutely wonderful.
Do it while you're young.
Ooh, we sound really old.
I know. What is it, my sweater?
That lunar project was... I wanted to ask him more about it. It's so fascinating. But at the same time, it's hard to put such a project into words. I'd really encourage you to go to their website and watch their videos of seeing the structure unfold. And because it's a collapsible structure. So once they brought it to Greenland, they expanded it and then inhabited it for 60 days. But it's hard to describe that. It's to put that into words.
I've seen a lot of projects like that in architecture school. I was actually a part of a team that did a project like that. We built a structure for like way up in the Himalaya mountains, like how you would survive in this temporary structure. But that's where it stopped, is like we came up with all these theoretical ideas of what it could be. Here's about what altitude sickness would do to you. Here's kind of what you would need. And that's about as far as you can take it in architecture school. But it was so beautiful to see that these guys actually took this to Greenland and stayed in it for 60 days. I mean, how insane are they?
That's true commitment. It's not just stopping at a certain point and being happy with that mediocre, half-baked idea. They want to see it through. Even they understand it's not completely realistic. This is not like actually going to the moon, but they are doing it. They're trying to replicate the environment as close to the moon as possible.
I feel like you could do a whole podcast on just a discussion about what it was like living there for 60 days. What did he do? Where'd they go to the bathroom? How did they cook food? How did they shower? All the things like that.
And it's not just the structure itself and the environment too, but they were completely isolated, had no other human contact for 3 months. And anything they did, they were completely self-reliant. So like he said, he had to be really careful not to cut himself or break certain bones or anything because there was no help around.
So SAGA could be classified as one of those 3D printing companies that is looking to explore how to exploit the machine and the material. They're not the company that sells the machine, but it's nice to have a designer or an architect looking into ways that this machine can be exploited.
Yeah, because right now this whole world of 3D printing is so new. We haven't really created subcategories under it. We just call every company out there a 3D printing company.
Yeah, and they're so different. I mean, you have Icon, who builds houses, and you have 20 Additive Manufacturing out of Canada that really just explores and builds whatever they want because they have the land, they have the machine, and they can really be creative with it.
And then you have SAGA, who are like these young up and comers who don't have the same money that Icon does, or maybe not even what 20 Additive Manufacturing does, but they have the creativity, and they're going out and trying to get sponsors and create these 3D printed homes on a smaller scale, but explore things like overhangs or leaning structures and facade designs. And that's extremely important because we have this incredible machine that can affect us in all these different ways. And we need people with different expertise to tackle all these different features. We can't have just the engineers playing around with it, or just the architects, or just the technicians. We need all these different players coming from different angles.
So you're talking about different companies exploring how to use this new machine that we have. And it's like this, it's the wild, wild west right now. Everyone's just doing whatever they want. People are seeking funding and getting it somehow. But it kind of reminds me of like the way that it could be explored by architects in particular is doing something like Taliesin West does in Arizona. This is a school for architecture and design that lets in very few students, but they're out in the middle of the desert basically, and they're required to live in the bunks that are in the one structure that's there, or they get to build their own out in the desert even further. So I could just imagine a school like that having a 3D printer and just the students exploring and building their structures out of that. That'd be really cool to see.
That's a very interesting idea. Didn't think about that. That's a very cultish school. Cultish.
Do you know if there are any schools that are working with a concrete 3D printer like this? I know there's a couple of people you've talked to that said they're partnering with universities.
But I feel like when they partner with universities, they're partnering with professors who are already experts in the material sciences.
Yeah, it's really just for material research.
Not so much with how to use the machine or what designs we could create, what new designs we could create with the machine.
My guess is because the material's so expensive.
So like we said, 3D printing is such a new field and there's so much exploration going on in that field right now. There's so much noise. Everyone's approaching it from all these different angles. No, it's not very structured, at least to us. Like material sciences is going on in one sphere and people are selling the machines in another sphere. Someone else is making the nozzle heads. But I think very soon we're going to have structured college degrees in 3D printing. It reminds me of when the term software engineering was only coined in like 1960s. Before that, it was always part of just other types of engineering in college. It wasn't its own separate degree. But I think very soon we're going to have 3D printing degrees, and it's going to be different types. It's going to be like 3D printing software degrees or 3D printing design degrees or something. Maybe in architecture schools you could get what do they call it?
A certificate?
Certificate or a concentration, I think that's another term, in 3D printing.
So one way that SAGA is able to do all these space projects and take on these smaller commissions is that they are building everything in-house. They are doing the design, they are doing the manufacturing. Unfortunately, that kind of limits your expansion. And I hope that they're able to keep this exploration going without running out of money.
I'm sure they'll try to seek money for when they get larger, but it's no different than, say, Hempwood, for example. Yeah, he started off probably with more money than Saga did, but they're doing everything in-house. They're figuring out this new product for the first time. They're creating their own machines to make the product because it doesn't exist out there. And Saga's trying to do the same. They invented a whole structure by putting all these different materials together, things that hadn't come together in that sequence before. So I think it's the fact that they have grown from 2 people to 11 people in just a year is a good sign. They're being recognized for their creativity and for their hard work and their innovation. And I hope they keep growing and they keep producing exciting projects.
Maybe it's a new type of architecture firm that's created because they have this in-house 3D printer at some point. I know they don't right now, but there will be a lot of companies popping up that have a 3D printer in-house, and so they can basically do a large portion of the project with the 3D printer.
So architecture firms turn into part builders too.
So it's more of an architecture and manufacturing together.
So Philip Lund Nielsen from Cobod, one of the largest 3D printing companies in the world, he actually introduced me to Sebastian. He said, you should talk to this guy. His work's amazing and he's going to blow your mind. And yeah, he did.
You want to repeat that with a Danish accent?
No.
So maybe we can have him on the show.
Yes, busy guy. But I'm going to try to get him on the show. He's already promised to be on our podcast and even on my main channel. I just have to get a hold of him and get him to sit down for an hour.
Work into his busy schedule.
So I hope you enjoyed our interview with Sebastian Aristotelis and our discussion on space architecture. Let us know what other topics you'd like us to explore. Join us next week for another episode on building science, products, and technology.